Cisco Certified Network Associate Day 40. Welcome back everyone, I'm Imran Rafai, your trainer for this entire series. Today we're going to look at 802.1x framework and AAA. So without wasting much time, let's get straight into today's class. And like always, before we go ahead, click on that subscribe button and click on that bell icon to be notified when we add a new video. Your like on these videos is going to encourage us to create new videos, so please feel free to hit on that like button as well. Our social media contacts, on the left you will find Networking Inc., our company's social media contact, and on the right you would find my personal social media contacts. For people who want to know my email address, imran.rafai@nwking.org. So what are we going to look at today? Today we're going to look at 1.7a, that is 802.1x, and we will look at 5.4, that is describe device management using AAA and TACACS plus and radius. Now, compared to some of the other topics that we discussed earlier, this is a describe topic, and both of them are describe topic. That means to say Cisco does not expect you to know the configuration, or it doesn't need you to know in depth on these topics. This is a describe topic, so it is going to be more of theory so that you know what all these mean. Let's look at a Cisco device and how did we log into Cisco devices earlier. Whenever we logged into Cisco devices, we configured the line password. So if you remember, we talked about a line VTY, and we said line VTY login, and then we put a password. What that means, it meant that the login, when we gave the command login, it said look for the password in line, right? So otherwise, had we said login local, it was looking for a local password configured by a username. So if you go to the global config and you type username Imran and password Imran, and if you go into line VTY and say login local, it was looking for that local password, the username and password that you set up, right? But the problem with that configuration was that both those configurations were locally configured on the device. So if at all, let's say your organization had 1,000 users, right? So each of those devices would have let's say username, and you will have 1,000 usernames and passwords. And let's say if you had 1,000 devices, then you would have 1,000 devices, and each of those 1,000 devices would have 1,000 username and passwords. That's fine if you really want to go and configure those username and passwords in 1,000 devices or 100 devices, whatever, a big number of devices, and you would have to have these usernames and passwords configured locally on those many devices. Now, best practices in security says that your username or rather passwords should be changed frequently, right? So if you have to change password for 1,000 users, you had to go to all those 100 devices or 1,000 devices and make those changes, and it's a tedious process. There is a better way. There is a better way of configuring Cisco devices so that you have control of usernames and passwords in a much more centralized form. So that is where a concept called AAA comes into use. AAA is nothing but authentication, authorization, and accounting. These are the three functions of a AAA. So what it basically does is you would have a central server. This central server would have a database of usernames and passwords, and your device, let's say a Cisco switch, when you try as a user, when you log into the Cisco device, instead of looking for a username and password configured locally on the device, it would try communicating to the AAA server. So let's call this the AAA server. So it will contact the AAA server and check for the username and password that you're giving, and if it works, it lets the user connect, right? So this makes it easy, because if there are 100 devices, right, and all those devices just need to be configured to the authorization server or AAA server, and no matter where you connect to those devices from, it would always check for the username and password from the AAA server, right? So if you want to change the password, just come to the AAA server. Once you change the password, that applies to all the devices on your network, right? That's brilliant, because now you are moving your database authorization, or rather authorization of username and password, to a central server. So in AAA, there are two protocols that we use. One is Radius and another one is TACACS Plus. Now Radius is nothing but short form for Remote Authentication Dial-in User Service, and it is described in RFC 2865 and 2866, right? RFC is request for comment. Now this is whenever a new protocol is proposed, there is an RFC that is created, and they describe the whole protocol. Then it's open for people to comment. If you think there is a better way to do certain thing, you can comment until they close the RFC, and then they get that protocol out, right? So until the protocol is finalized, there are a lot of chances for anybody involved to contribute to that protocol. So RFC 2865 and 2866 describes the Radius protocol. It's an open standard. It was developed in 1991, right? So it's quite an old protocol. It was basically used for network users. So basically, a Radius is, if you want to control user authentication, let's say user gives username and password, then you would use Radius protocol. It uses UDP 1645, 1646, and new devices have UDP 1812 and 1813, right? But basically it uses UDP protocol. Radius supports three functions: authentication, exec authorization, and exec accounting. Now what that means is authentication tells the device if you are you're authenticated to come in, like you are allowed to come in or not, right? Authorization tells the device what are you authorized to do, right? So are you authorized to do a certain command? Can you make use of configuring certain things on the device? So that's what authorization tells. It tells you the level of authorization that's available for you, right? So do you come at a privilege 10, or you come at a privilege 15, or you come at a privilege 5, right? So at what level you're authorized, right? That's authorization. Now after you come in, what have you done there? Like you might change the routing protocol there. So there should be an accounting which records all those commands that you type in, right? That's where accounting comes in. So these are the three functions. Are you allowed to log in? At what are the configurations or levels that you are authorized to use? And what have you done there, right? These are the three functions it does, right? It supports Radius. Now TACACS Plus, on the other hand, it's the short form for Terminal Access Control System, and of course the plus is because this is a protocol developed by Cisco, and it was derived from the old TACACS protocol, which was an open standard protocol. Even though Cisco developed this protocol, this was released as open standard, right? So anybody can use this protocol. So that's TACACS Plus protocol, and this is used more for device administration than user administration, right? So devices, you can configure TACACS Plus with devices, and you can tell if let's say you connect a printer, you can tell what those printers can do and things like that. It uses TCP, so TACACS uses TCP. You need to know Radius uses UDP and TACACS uses TCP for one reason. If you're an administrator and if you have a firewall in between your end device and the authentication server, you need to open relevant ports, right? So if you're using Radius, you need to allow UDP traffic to go through the firewall, or if you're using TACACS Plus, you need to allow TCP traffic to flow through the firewall, right? So this is very important. You need to know the port numbers. TACACS Plus also supports a couple of more functions like command authorization, right? So in Radius, you can just tell that this user goes at privilege 15 or privilege 10, but it can't tell you in privilege 10 what are the commands that you are authorized to use. But in TACACS, you can go to that granular level and tell, okay, even though you come in at privilege 5 or privilege 10 or privilege 15, what are the commands that you can use, right? You may want to give that user a lot of commands, but not configuring let's say for instance routing protocols, right? So you can go to that granular level and either allow the user to make those configurations or not allow the user to make those configurations, right? Similarly, even command level accounting takes place. You can tell exactly what are the commands that you applied, so that accounting also can be recorded by TACACS Plus. Now, on a typical switch, what happens is, let's say there is you go to a conference room and there is a wall socket. So you take your laptop, right? This is a laptop and you plug in there. Now, if you remember one of the older videos that we discussed, especially in the ICND1 part of this course, we said there was something called port security. We discussed port security and we learned port security. What does port security do? It depends on the MAC address. It can block that port. So if at all that MAC address is configured for that port, the port security can disable if it's a different MAC address than the one that is configured, right? Port security is something that is got limited level of security where you can disable the port, but on enterprise level, it's not easy or it's not practical to have protocol port level port security, because you might have a lot of people connecting to that port, and you can't just have one or two or an X number of MAC addresses that you can pre-configure there, because you might have a lot of people connected and you want a level of security where you don't want people to misuse it, but still you don't want to restrict people from using that port. Now, typically there is a framework called 802.1x. Now, 802.1x is a framework. Over 802.1x, you can use a protocol called EAP, right? Now, what this protocol does is, now if you have a switch port, like when I say switch port, I mean the physical port in a switch, right? So this port on the wall in a conference room is actually patched to a switch port in let's say a 48 port switch, right? So you have to go to each of those ports and configure 802.1x. If you do, typically what happens is when you connect to a device, every traffic, DHCP, TFT, IP, whatever, is all blocked except for one special protocol called EAP over LAN, EAP all, right? EAP over LAN. Now, EAP over LAN traffic goes through, and switch does what it has to do. It contacts the authentication or AAA server. If the server says, fine, the username and password that you're giving is correct, it will open that port and all traffic after that will start going on. If it says it does not let that traffic go through, nothing changes and only EAPOL traffic will pass through, right? So this is a very simple explanation of what 802.1x does. If you want to look at 802.1x process, 802.1x process basically contains three components. So there is a supplicant. Now, supplicant is typically a software that's on your computer. So most of the newer operating systems have a supplicant software inbuilt, but if you don't have, you can have third-party supplicant software. So it's a software. Why do you need that software? Because when you connect to a 802.1x enabled port, like I said, all traffic would be blocked. Basically, you will not even have an IP address. So this device cannot get an IP address. The only thing that I said that will work is EAP all, right? EAP over LAN. Now, not all computers know how to frame EAPOL, right? You don't know how to create that frame of EAPOL. Now, that supplicant software would be able to create frames of EAP over LAN, right? So it creates those EAPOL frame, right? So that's a supplicant. That's one of the components. The second component is an authenticator. Now, authenticator is the device. Like, let's say, for instance, in this case, Cisco switch. That's an authenticator. That sits in between. What it does, it just relays information. Whatever the supplicant sends, the authenticator takes that. It creates a new IP packet, right? So it depends. If it's radius, it uses UDP. If it uses TACACS, it uses TCP, right? So it creates a radius packet or a TACACS plus packet, extracts the EAP content that is on EAPOL, it puts that onto the packet, right? So it takes the EPOL frame, takes whatever content, takes the data out, puts it onto an IP packet, either radius or TACACS, and sends it to the authentication server, which is the third component, the authentication server. So authentication server looks at it, it says if it is correct, yes. If it says it fails the authentication, it cancels. So let's look at the process a little more. So initially when you start, the port is blocked, right? The first message that it sends, the supplicant sends an EPOL start message. Now, EPOL start message is not mandatory. Not all devices need to send that. Even if it doesn't send, an authenticator which has 802.1x enabled on the port, that port will every few seconds or few minutes, depending on how you're configured, it would send an identity request message, right? So if you send an EPOL start message, it immediately sends an identity request. When it receives the identity request, the supplicant will send an identity response. Let's say that is when you send the username. So when it asks for identity request, it says, okay, username, I say Imran. That frame comes to the authenticator. Authenticator strips that data, which is Imran, and puts it onto an IP packet, sends it to the authentication server. The authentication server says, fine, I can see an Imran username. Now I challenge you to send me the password. So that's the access challenge. So this message is called access request. The reply is called an access challenge. Don't worry, you don't have to really go in depth. You don't really have to know the messages and message types, because like I said, these are describing, right? If you look at the exam topics, it says describe, so you really don't need to go into this level. But just for information, I'm going to say, just for information, I'm going to put it here. So if you're interested, yes, go through. Otherwise, like I said, just skip through these topics. So access challenge, it sends a message asking for the password. So authenticator sends it to the supplicant. Supplicant says, fine, I need to send you the password. So basically it sends a password, but there are a few more steps that happens in here. There is a negotiation that happens between the authentication server and the supplicant of what tunneling. No, you can't send password in clear text. They need to create a tunnel, right? You need to create an encryption method. So the supplicant and authentication, either they decide to use EAP TLS, which is a tunneling protocol using TLS, or they could use PEEP, which is a protected EAP with other functions like Microsoft CHAP, right? So there are other communication that happens between the authentication server and the supplicant. But basically, after they do that, it replies with the password. So password goes through a encrypted tunnel that goes with an access request to the authentication server, which looks at the password, and if it is success, it says accept, access accept. If it fails, it says accept reject, right? So finally, if it's a success, it sets a success message on EAPOL, and finally, if everything works, that port gets opened, right? This is the process that is taken to get a port from a shutdown state, or rather filtered state, to a open state, right? So basically 802.1x is a process or framework that helps you have a much more advanced level of security than the old port security that we discussed. Ideally 802.1x is enabled on wireless devices. So basically it's the same thing. On wireless devices, you'll have a wireless device. So let's say it's a wireless device, and you would have a laptop that connects. So you'll have multiple people connecting to that wireless device. So this wireless device contacts the TripleA server, authentication server, and depending on what comes, you can depending on TACACS or radius, you can tell what VLAN. So basically you can tell that device number 1, and this is device number 2. So you can say device number 1, depending on the username and password that was given, you say that this device needs to be placed in VLAN, right, VLAN 100, and this device need to go into VLAN 200, right? So all traffic now coming from this device will automatically go to a VLAN 200 traffic, and this will go into VLAN 100 traffic. So these are all the things that can be done using 802.1x. So this is a very short video. We looked at 802.1x and AAA with Radius and TACACS Plus. We'll be back very soon, and we will start getting into very complex topics, like one of the most requested topics was for OSPF and EIGRP, and we'll be getting into OSPF and EIGRP very soon. So stay tuned and don't forget to hit that like button and subscribe to our channel. See you all very soon.